Now, in the last example, it was just a very short program and it didn't really show you all of the functionality of the assembler. So let's work through another example, which I think you'll find quite interesting when I tell you after we've talked over it, how I generated it. So we're going to go back to our old friend, the Fibonacci series. It's a nice little one that we can use that shows up some of the functionality within the assembler. Now, this is the code here that will generate the first 10 Fibonacci numbers. I'll just talk my way through quickly just to show you the constructs within the actual assembler. I'm not going to talk you through how the code works. You can have a look through that yourself, and you've seen the Fibonacci before in the previous course. But we just want to try and get an idea of how the assembler works. So again, we have the origin 0 cross 8000. Now, the thing to note here is that it can be lowercase cross or uppercase cross. It doesn't matter. I've tried to make the assembler as user friendly as I possibly can, okay? So that if you make small mistakes like that, then it doesn't really matter. Another thing as well is that if you miss out the origin altogether, so if you just completely take that line out, it'll just make the assumption that you're starting from the 0 cross 8000. Now, another thing to note here as well is that you don't need to put it in hex. You could put it in purely in decimal. So you could put the origin is going to be, it could be 0b, okay, 0b, and it could be 0101. So 0b means it's in binary, okay. So it will convert, the program will actually convert everything into integer values, and it'll work through in integer values, and then at the end it'll pop out the hex number anyway, okay. So you can put it in hex, or you can put it in binary, or you can just put it in straight decimal integers, and it'll work in all three bases, okay. Now, I like to use the hex because that's how the memory is allocated, okay. That's whenever you go into the actual RAM or the ROM, you'll see it in hex, so I prefer to work in hex. Now, another thing to note here is that you can put in comments, so you can put anything after a colon, it knows it's a comment, and you can put the comments anywhere, you know, in a new line here, or you can put the comments at the end here of an instruction, and it will just cut out the comment. So that's quite handy. You can put comments in. Now, another thing that we really need is a looping structure. So again, we can create loops. So in this instance here, in order to create a loop, the loop has to be, the actual words have to be in a mixture. It has to be in lowercase letters or numbers, okay? So I can't create a loop that is something like this, okay, because they're all uppercase, okay. I could create one that looks like this, okay. So you can use one uppercase or multiple uppercases, but if they were all uppercase letters, it wouldn't recognize it as a loop, okay. So all uppercase letters within one separate word is always going to be defined as an instruction. So you can see here that all of these are instructions. They've all got uppercase letters. So the actual beginning of a routine, or if we like to call it a loop, it can't be all uppercase letters. So the way I do it is I just basically keep everything lowercase. And the beginning of a loop, it's finished off with the colon. So if you miss out that colon there, it gets confused. It doesn't know what you're doing, okay? So you have to have a colon there. Now, that's the beginning of we really call it a label, okay. So that's a label here, and if you come down here, you can see some of the code here. The store, there's the increment command there. We've got our exchange register, which we're using, and a decrement. We've got a jump of 0. Now you can see here the jump of 0 to the end loop. So end loop is another label. So there's end loop here, and the end loop just goes to the clear flags and the end. And you can see here this JMP to loop, it'll jump back to the label here, loop. Okay, and as well, you don't need to have them in separate lines here. Okay, you can have actually the values in together. So for example, I could have this here, Control C space Control V. Okay, so it will loop. So that's the loop. So whenever this comes back up, it will jump to loop here and it will start running from this point here. Okay, so you can do it like that if you want. I prefer not to. I prefer to actually have it sitting like this. So you've got the loop and it's a colon and there's an empty space, and then the loop starts below, and I like to indent it. It just looks a bit neater and tidier. So that's all there is to say about the actual setup here. You'll see some of the commands, and you can read through the commands. Remember that all values that relate to a literal value begin with a hash, and all values that relate to a memory location they don't begin with a hash, it's just a number. I don't think there's anything else to be said here about the actual the way the code is, the general setup for the code. I've talked through everything that you can see here. Now, one thing that is interesting about this, and you may be surprised to note this, and I was quite surprised myself when I started doing this. I went into ChatGPT just to test out, so that's the AI chatbot that you may well have heard of. So I put in to ChatGPT my entire instruction set, so 90 instructions. I also put in to ChatGPT the instruction format. So my format is the opcode, and the addressing mode, register 1 and register 2, and register A, register B. Register A is a source and register B is a destination. And I basically described the instruction set that I have, and after going through a description of it, so it was quite lengthy and detailed, the amount of information I put in, but I gave it enough so that I could then say to it, can you generate the assembly language code using my assembly language that will produce the first 10 Fibonacci numbers? And it generated this. Not quite this. There were 2 or 3 places where it had made small errors. Okay, and it was just a case of me having a quick look through it, and then I pointed out the errors to it and I put it back in, and within 2-3 iterations we had generated the code here, and it's all commented and it all looks neat and tidy. It all comes out like this. So I tested it and it works. Of course, you don't just take stuff out. You read over it and you understand how it works, and it's, you know, but we've done the Fibonacci series a few times, so I know how the code works here. Now let's go ahead and generate the machine code for this Fibonacci program using the assembler. Now before we do that, we can actually go in and we can look at the first pass of the assembler, and we can compare it to the original program. So here's the original assembly language program on the left, and we've got the first pass of the assembler on the right. So you can see that in the first pass of the assembler, we don't have any of the assembler directives. For example, the origin 0x8000, and it's got rid of all of the comments, and it's replaced all of the labels here with the actual positions within memory. And you can see here that all of the literal numbers have got a hash in front of them, and all of the memory locations have got just the number without the hash. So this has generated now the first pass. Now the second pass, it takes this code here and it generates the ones and zeros, which are represent this actual in these instructions. So let's go ahead and we'll load it in and we'll run it. So we can reset the simulation and we can get into the RAM and we'll open up the machine code in hex. So this should generate the first 10 values of the Fibonacci. And you can see it starting to generate now. We've got 1, 2, 3, 5, 8, and then D, and it's running through in hexadecimal. So you can always check these numbers if you like. So that's the first 10 Fibonacci numbers. So this has been quite an interesting video, not necessarily in terms of the fact that we've used the Fibonacci numbers, the fact that I've generated the code using an artificial intelligence chatbot. That's all for this video. Thank you for listening. I will get you on the next video. Goodbye.